So we have 9A, which will be done at section 9.6. Then we have 9B, which will have our Taylor and Maclaurin polynomials, and a couple other things. 9B is shorter, I think it's 4 sections, and then we have 10, which is like 2 sections. 2? 2 or 3?
Because I'm running out of
We have to go back to polar for integrals. We did polar derivatives, but we didn't do polar integrals. And then there's vectors, but they're so easy. Because, they barely do anything with vectors. The big one is chapter 9.
Nice.
The big one is chapter 9.
Can we
And
go
polar.
back to derivatives of polar?
Yes, we'll go back to derivatives and polar when we do integrals. We'll review.
Chapter 9 is not that bad.
But remember how we did in our quests?
Yeah, only the words.
You got one wrong. You put diverging, it was converging. Or vice versa.
Yeah, I know.
Okay, so 2 things. First of all, the limit as n goes to infinity has to equal 0. Do we know that already?
Yes.
Because if it didn't equal 0, what would say divergent?
Entrance.
Yeah, nth term test. So we know it has to be 0, but then we're like, oh, but how do we know? So first of all, the limit has to be 0, and then second of all, the second or the further term, the n plus 1th term has to be less than or equal to the nth term. So we're going to have to actually be setting up terms and saying, how do they compare? Obviously, the series diverges if the limit does not equal 0, and I'm just going to put in parentheses nth term test. We should already know that, right? Okay, so what else do we have? We have, first of all, what's it take to be alternating series? The terms alternate in sign, positive, negative, or negative, positive. You'll be able to tell it because you see -1 to some power. And as you have even powers, odd powers, it's going to go back and forth between positive and negative. The idea of the alternating series test is that the series will converge if the terms eventually are decreasing. It might take a while to do so. Write out the first few terms to get an idea. Okay, so the terms, now I want you to underline that word, eventually. Remember, sometimes we have to split up the terms, right? If the terms eventually are decreasing. Eventually are decreasing, that's an important word. Okay, let's get to some examples. So we have our alternating series test, all right? The limit of the nth term has to be 0 as n goes to infinity, and we have to be able to show the n plus 1th term is less than or equal to the nth term. Oh, sorry, I forgot. With alternating series, there comes one other really important idea. Absolute versus conditional convergence. Wait, what? Absolute versus conditional.
You see, what was the little, like, gray words you asked me to do?
Oh, the gray words was, first of all, it might take a while to do so. It's the idea of we might have to split up a series and have the first few terms be separate than the next one's going to infinity. Might take a while to do so, and then write out the first few to get an idea. Usually helps. If you can't see it right away. Alternating series can have different types of convergence. Alternating series can have absolute, or it can have conditional. It can have absolute, or it can have conditional. Can you guys see the test? Let me zoom in a little bit. And if you guys notice with the absolute and conditional convergence, what's the difference? Absolutely convergent, we're talking about the absolute value. Conditionally convergent, well, the absolute value diverges. So with alternating, if we have these new ones that can go positive, negative, we're going to look at the series in and of itself with the positive, negative, but we're also going to look at the absolute value. Now, why is that going to be nice to look at the absolute value? If we get the absolute value of alternating, what do we not have to worry about? Yeah, we don't have to worry about positive, negative. If we take absolute value, there's no problem because it's all positive now, right? So, we're going to have to consider for absolute versus conditional. We're going to have to consider the absolute value, but that's nice because we can go back to our old test and say, okay, I don't care about the negative 1 anymore because absolute value would say it doesn't matter. I didn't say pick up in your desk. I just mixed it up.
I thought you that's what the I was like, what? I'm gonna sit in the chair for now. I'm gonna wait till all these tours to fade out.
Why are they gonna fade out?
I don't know, they just kind of randomly happen.
No, they've never happened at all this year.
Guys, here's the idea. As you're writing the absolute and conditional convergence deal, as you're writing it, does the absolute value have to converge?
No.
No. So, well, there's two different strategies for testing. That's what we're going to write in the bottom. There's two different strategies for testing. We could test for alternating series. You could always test the absolute value first. Why? I don't need a new test. But if the absolute value doesn't work, I don't know and I have to test again the alternating. Does that make sense? If the absolute value works, I know it's absolutely convergent, so I don't even have to test anymore. If the absolute value converges, done. But if the absolute value diverges, I don't know about the alternating one. I have to still check it because it could be conditionally convergent. So then this whole little bottom thing, the strategies for testing. The idea is we could test for absolute value every single time, but sometimes it'll give us our full answer and sometimes it'll send us on another test and say, wait, you're not done yet, you have to keep checking. This is endeavor number what, 24? 23. How did I forget so fast? Oh dear, I don't know. It's a Monday.
It's a Monday.
So we have, oh no.
What happens on Monday?
There's this silly YouTube video about it's a Monday and this guy's being silly. It's all about a shopping trip that went really badly. Anyway, silly. Students 3 years ago would watch it a lot. 2 years ago?
I feel like camera.
It was Hannah Scott.
You haven't seen it?
It was Hannah Scott and then it went to Tamara and then it kind of died out last year.
We're bringing it back.
Okay, so strategies for testing. You can test for absolute convergence first. This isn't something necessarily to memorize, but just something to understand. If convergent, then absolutely convergent. If divergent, never mind, that looks weird.
Is it then or than? Then, right?
Then, as a result. If convergent, then, so if I test for absolute convergence first, what am I testing? I'm going to test ignoring the -1. So if I test for absolute convergence first, I'm testing ignoring the negative, positive, negative, positive. I'm just looking at the term without the -1 part. If it's convergent, absolutely convergent, I'm done. Awesome, that's so easy. If divergent, I still have to check the convergence of the alternating series. I have to check to see if it's conditionally convergent. So you can test the absolute value right away. And sometimes it'll be like you're done, but then sometimes you still have to check the alternating series anyway. And then the other strategy is like, well, sometimes it's not even going to work, so you should just always start by testing the alternating series, and that's what the other one is. Test for divergence first.
Wouldn't it be simpler to do it that way?
To test the absolute value.
No, the other way.
Oh, to test the divergence? Yeah, probably. Test for divergence first. test the alternating series using the alternating series test. Okay, so now we have this whole like, convergent isn't going to be enough of an answer. Divergent is. Divergent's still a good enough answer. If it diverges, if the alternating series diverges, the whole thing diverges, we're done. But convergent, now we have two different types. We have absolutely and conditionally, and it's all because of the nasty alternating signs. We ready for examples? Okay. Examples. Here we go. It zoomed in enough. Okay, I can make it a little bit bigger.
So that's the one that was on the WCC.
Part D, you wouldn't have known what to do with yet, because the limit is 0, but you wouldn't know if it's conditionally or absolutely convergent.
But now we're divergent.
Now we would. All right, kiddos.
Homework.
Keep it up on the counter too.
How do we do? We could go ahead and look at it really quickly and just make sure, remember, the important thing about alternating series is if it's eventually decreasing. Why is it alternating series? You can tell, right? The -1 is going to be in powers of -1. If I plug in 1, it's going to be a positive, right? And then if I plug in 2, it's going to be a -1/2. A +1/3, and a -1/4, and it keeps on going. Okay, it's alternating. We got it, right? I could ignore the -1. I could ignore the -1 and look at 1/n. But guys, 1/n.
Is divergent.
So if I was to do, the one way is to say, first of all, think about the absolute value. And the absolute value, I can say, oh, sweet, ignore the -1 and just say 1/n. Right? Because absolute value of the negative doesn't really matter. And then I could say, well, 1/n is divergent by what? P series. But the problem is, does that mean that the whole thing is divergent? Look at your absolute and conditional. Even though the absolute value is divergent, does that mean that he can't be conditionally? I don't know. I have to go check. Now, if this was convergent, I'm done. Absolutely convergent. No more. Done. Right? That's why it's sometimes nice to check absolute value. But I still have to go check the alternating series because that wasn't enough information. I know it's not absolutely convergent, but I don't know if this is still maybe convergent even though that's not. So alternating series test. Okay, how does this one work? First of all, the limit as n goes to infinity has to be 0, right? Of the non-sign part. So the limit as n goes to infinity of 1/n does equal 0. Check. But what's the second condition? Oh, butterscotch.
m plus 1 smaller or equal to.
Yeah, so I have to actually find a sub n plus 1, which would be 1/n plus 1. And I have to compare it to a sub n. But guys, look at the 2. If I keep on increasing 1, 2, 3, 4, 5, is this one going to be less than or equal to that one? Less than? Yeah, because his denominator is going to be bigger. Does that make sense? So therefore, since the absolute value is divergent, but since it meets these conditions, then I could say that my series is conditionally. Oh, I get it right. And I'm done. Conditionally convergent. You guys can go. Conditionally convergent.
We should put a bell outside that door. Or like have a secret knock,
Secret knock.
so I get into a chair.
Let's see how to do number 2.
Heading number 2. The limit is 2, so completely divergent.
Oh, okay.
If the limit's not 0, Completely divergent.
So if
So it can be absolutely convergent, conditionally, or divergent.
Oh, there was,
if the function
remember
didn't
when we all
match
taught the snack bar periodically it was CGD?
and if
Do you remember when Miss Penny never gave
Yeah,
back
completely
any work?
divergent.
Do you
So that's why the
Remember
difference between, because
when
nth
Mr.
term,
Choi
if it's
smiled
divergent, I
and
can say
left?
completely.